Good morning. Good morning, everybody. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India on this day, February 30, 2022, Sunday, 3:20 am. मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ। दिनांक फरवरी 13, 2022, रविवार 3:20 सुबह के। I am here again back to you regarding discussion of very important topic which applies to everyone. And those combination of topics: quality works, projects, coordination, communication, concrete, civil field engineering, reliable engineers, work contracts, work safety, engineering designs, construction methods, work claims, organizations, and again quality. I want to keep concentration on quality and coordination, which dominate my talk, supports all other names as I've given. Coordination, communication combined, then engineering and reliable engineers combined, and of course contracts and designs combined, and all other whatever given here is. Now you can also see this my email ID on my identification board. It is suraj_engineer@yahoo.co.uk. If you wish, you can write. You're welcome. You can write on this address for whatever query. I shall be pleased to review your query and answer or respond to that. And also this is competency certificate, which is called International Professional Engineer India, valid for 5 years. And this is another competency certificate, which is Chartered Engineer India, based on complete competency. And this is membership, fellow of Institution of Engineers India. And also this is file that amounts to that entitles quality and coordination. In continuation to follow up to coordination, engineering projects and engineers, concentrations remains on both files. And this chartered engineer certificate, every corporate member of Institution of Engineers India is legally authorized to use this title. It's for your information, and because I am from Civil Engineering Division of that institution, which means I am basically by qualification a civil engineer, and I call myself coordination engineer also because of my experience. Site engineer, coordination engineer, engineering designs, construction, all such activities have been my friends, and this is my membership. And currently I close this both because I don't want to keep all files open. And here is quality and coordination, which is very important file, and particularly I am inclined to talk about our nation, Bharat, India. And Bharat, India speaks about itself in quality and coordination, but we have to understand first quality and coordination. And also this is a file, another one in continuation to this file, that is coordination engineering. Because coordination engineering is very important, though it is not a discipline type, but it's a ruling type, means it's a decision maker process. We can call coordination engineering as a decision making process. When you find problems, when we find clashes, and we find whatever we can say, that is that file which have its own importance. Because if we intend to get quality, and it's not a question of if we get, but we have to. Quality is a must. It cannot be allowed to stay in dust. It has to come out of dust and it has to do its work, and that's what quality is, which cannot be measured in terms of units or in terms of effects, in terms of its service power, in terms of safety, in terms of long-term living or durability, we call that. I have selected these words, these titles like coordination and communication, as well as concrete. Concrete means we have to work like concrete, and also concrete means concrete material. My first understanding is we have to work like concrete, solid, having many properties. Same way we have to combine ourselves with our future, our perfect actions, and that happens through various modes of communications, various modes nowadays, not just one or two modes, a line chain of various mode communications, and that various modes of communication takes us to conduct coordination. Coordination means to conduct studies of various provisions, whatever provisions we have in technical effect or in documents, effect on drawings or on documents. We have to understand, we have to study all in mutual application, mutual form, we can say interrelated mutual understanding. And that understanding can be called, if it is done properly, a comprehensive study. And that comprehensive study, when done, when it's conducted, it discovers so many, you can say, non-acceptable relations, or we can say conflicts. There could be conflicts on drawings, details among itself, and there may be contradictions of these drawings to required specifications, or we can say required technical provisions. And to discover that is very important before we do job. And if you do job before discovering and resolving these conflicts, or you can say clashes or incompatibilities, we shall certainly perform work not to requirement, or we can say non-conforming work, it shall be called. And that's where we have to link all this together. There is no independent engineering which can be applied onto such a state. It's a combination of all engineering, you can say overlapping combination or interconnecting combination or interlinking combination, whatever you can say. And that's what we say. When you say interlinking, it's a kind of communication network on which information flows, and we have to see information, whatever flows on this network, do not fight with each other, do not have any conflict, but move in unison, so that every information is useful, every information helps each other information. And that's what we can say. If we understand that, we have to move like this. At this point, that is called piece of coordination. That information, whatever information, essential information, defined information, being required for some work, must be there all time when work is being done. And if even one information is not available, or if we do not understand why it's not available, or we say, okay, let do as it is, in that case we can say we perform substandard work. There are so many ways work is performed, not one way. And you can say we talk in general. We talk of contracts, because contracts is only a can say successful way nowadays, that we have to give contracts to someone for construction, or contracts of supply, or contracts of design, or a combination of all this to one person or one party. And that contract itself is a world. Contracting world means you have an engineering world actually. That contracting is nothing. It's not simple contract. It's not contract you go and buy some vegetable, or it's not a contract just take a ticket and fly. It's a contract for many months to come. many years to come. Responsibilities and liabilities and all, you can say, further responsibilities, warranties, all these keep you binding when you are a contractor, and also when you are an owner or a client, you are also bound by contract and by people, because ultimately whatever product you raise, you produce, that shall be bought by someone, end user, and that end user is real client, of course. End user is unknown at time of design, at time of construction, but ultimate honor is that which must be kept in mind by engineer, by contractor, by owner, while doing their jobs, respective jobs, and resorting to whatever required actions. It's not honor. That is honor, as I said. It may be user, consumer, or end user, or you may say whosoever. How many hands change on that, and that material, that substance. Everybody has ownership for some time, and we have to keep that in mind. If there is some risk, on what your product, this risk is not yours, this is not owner's risk, this is that person's risk who uses that product, manufactured product, processed product, or you can say whatever product, construction product, service product, you may say. That's why we keep all these subtitles in hand when we talk of quality. Quality means product, quality, service quality. Quality means overall quality, quality means individual quality, quality means specification required quality, or you can say good practice quality, or conventional quality, and quality means quality of human resources, quality of use of machines, quality of use of materials, or you can say in its complete network of quality, that is a standard product. And engineers, if perform in such a way that they don't cheat anybody, they keep themselves intact of an engineering requirement again and again, and you can say we can trust what they do for quality product. Such engineers, we can call them reliable engineers, not just for name's sake, but for orientation to get objective. Same way, we have to understand contracting, we have to understand designing, we have to understand execution, and we have to understand each and every stage of a project. That is an important point here. Means I always refer to quality and coordination engineering. And I say, I'm not claiming, but I feel, and I whatever have been observing for many years, that we have no guaranteed quality. We can't claim that we have been working in whatever work, whether it is industry, it is manufacturing, it is construction, it is whatever you can say. I doubt about quality, and it is proven fact that people are not very much inclined to think of quality and to talk of quality. They assume quality has been working, and they are not serious. They are not serious about coordination, and coordination is a very significant part of life. We cannot say we don't have confidence in our work if we are not sure of coordination done. And coordination is not simple speaking, or it's not a post office box. You got this information and pass it to another one. I have been told many times by my clerks or suggested that this is what is management. Just collect information from sources, give to other person. If that is management, then there is no requirement of management. There is no requirement of those people who have very high profile degrees in management, because coordination is no use for them. They are confused with terms called coordination and liaison. They just want to communicate something and they think this is coordination. I don't accept that. Coordination is a technical work, complete technical work, engineering work, scientific work. Coordination means you have to get complete information. You should know which information is required. If you do not know that, you cannot do anything. That means you are not clear about engineering world. You are not clear about engineering requirement. And you can say you are not clear about engineering. And if you are not clear about requirement, this means you have no clear conception. And engineering requires clear conception, confirmed conception prior to doing something. That is beauty of engineering. Engineering itself requires analytical study. If we do not analyze whatever we do before doing and after doing, whether we made any mistake, you cannot say that you are on engineering path. Engineering, what we understand, is not same as it is done. I don't say you get physical engineering only. No, it's not physical engineering. Engineering is never physical. Physical is only action. Engineering is intellectual work. Lot of design, lot of preparation, lot of documents are required before something can be affected physically on works or in manufacturing or in process. Lot of designs, lot of research, a lot lessons from mistakes in past. All those are conducted. And when so many actions are required, so many actions are to be done, how can we say someone can sleep? How can we say that? Just think of that one. And then I would say, if we sleep, this means we are not active. We are not active. How can we be active if we sleep? Sleep, the requirement of sleep to schedule is one, but sleeping when eyes are open, when you are not in bed, at that time sleeping, is not acceptable when you work in profession. When you work something, that is what I say. I don't want to see you sleep with open eyes or while you are not in bed. Sleeping means your thinking is zero. Sleeping means you are carefree. Sleeping means you can't understand responsibility. You don't want to be active. That's what it is. And this means also that you shall sleep from supervision viewpoint, from controls viewpoint, from administration viewpoint, and there will be every way that leads you to bad work, because you have not been interested, you have not been involved with quality and coordination. If you can't coordinate, you cannot understand what was required to be done and what I have done. It's not specific answer, it's not specific explanation. It's based on experience and based on track records that coordination is general term as well as coordination is very specific term. It's not measurable but affectable. If you want to see effects, you have to be with that system of coordination. And that system is also, you have to design yourself which way you have to go. No university, no institution can teach you. They can just guide you something, but authorship you have to take yourself. which way you have to go. Maybe you become exponent of some system, possibly, and that is much better. If you are intellectual and you believe in analysis, you believe in thinking, you believe in doing something based on complete analytical thinking, then finding solutions, initial solution, refined solution, or you can say oriented solution, which you have to apply. And therefore, it's a very significant process that we have to understand what we have to do. So I say, I don't want to sleep with open eyes. I don't want to rest without sleeping. I have to keep my mind active in technical requirement. We are active in other requirements. But main is because we have to sell some item to some user, and then yes, user has to use that item. We have no right to disappoint user. That is first requirement. We have to provide what we are paid for. That's also another requirement. Likewise, there will be so many requirements that we have to fulfill. And that's very important point. So I call that quality cannot sleep and should not sleep. Coordination should not sleep. Maybe not all hours, sometimes can rest. But that should be within limits when work is done. So that's why I say, as far as profession is concerned, we have to use our work, we have to bring our actions to, you can say, to stay with quality and coordination. Otherwise, we just remain in doldrum. And as far as our country is concerned, Bharat, India, and that has to speak about itself. And when it speaks about itself, it says we cannot work in profession without quality and coordination. And we have to be friends together for all others, because we are standard nation. We have to make ourselves standard. We are not currently that status. I'm not interested which level we have in world. I'm interested that we have to think about profession, not in terms of just learning from education point of view, but from working point of view. That's much more important as far as applications are concerned. And therefore I want to keep quality with me. I want to keep coordination with me. I do not want that quality and coordination activities must be off my mind. Because everybody is not well organized. Everybody cannot conduct such exercise of quality and coordination. One should have long experience in professional disciplines. One should have enough mind to think of, to analyze. And one should have patience. And one should have capacity to understand problems. What are problems we have to face? How this problem come up to this level? Where is source? And how we can solve it? And if we are able to solve this, means we shall certainly find permanent solution to that. That is beauty of technology. And we have to sharpen our minds. That's another point of view. Because these days sharpening of mind is not considered essentials. And reason is because of computers. Computers have changed our calculation style. Our mind has become, a kind of stop and arrangements. Because there is no construction joint, it should be there. I say when you use computers, your calculation power is certainly reduced. This means your calculation mind, property of mind that calculates, is not owned by mind now. It has been overtaken by computers. And computer success is dependent on how it has been programmed in the software. So it's very difficult. It means previously engineers used to be calculation master. Engineers used to be analytical. Engineers used to be reasonable. They have to give reasons. And now I think nothing as such, except that more and more walking towards software and not towards real work. That's the difference. Well, I'm not blaming this to everybody. System has changed, working style has changed, facilities have changed, yet human has not changed, quality has not changed, communication has changed. Yes, there is a difference. Previously, we used to take time to have some information reach somewhere. But now time is not that much expensive because using emails, using media, using digital world, we can save time. But that is also an excuse for something. Even if we don't have all this, quality still can be maintained, there's no problem. But it is to be established, there is no other way. There is no second supposition on that. It has to be established permanently, and particularly in engineering profession and also in other walks of life. We cannot do. And that is very much true. Question of quality, question of safety, and question of technical knowledge. All are very significant in profession. But because we have some lacuna somewhere, and that lacuna is in quality as well as in production. And lacuna also is happening in coordination. We have to be very serious about that. Coordination, we know it's our life part. It doesn't happen only in engineering work. It happens everywhere in our life, sometimes directly and sometimes indirectly. So we have to fix ourselves as far as quality is related. We have to make ourselves strong to do quality work and to define quality at every step. We cannot simply say this specification was used in those days and now it's obsolete. No specification can be obsolete if you know what you have to do. There should be no competition in this. It is technical work. There can be amendment made to this, whatever, but we cannot say it's obsolete. We can say there can be no compromise on quality, not at all. We don't accept any compromise. That should be our will, our determination. And if we cannot do that, somewhere we are at mistake. And we also say there's a distinct system, there's a distinct way you can say a difference between what is quality and what it is, how it is done. There can be compromises made, but compromise is not an alternative answer. It should be perfect work. Why you say alternative? We don't need that. Work is work. Work is quantity. Work is quality. Work is safety. Work is design. Work is standard. We have to understand this point. Work is never done in one go. It's a complete process, sometimes in our control, sometimes beyond our control. And that is why I say we can define system of our organization, we can define everything from commonplace point of view, but if we say we have to use our system, innovate our system, or we have to think of from original viewpoint, and if you start thinking that, in that case, engineers can change entire scenario. Well, I should not be bound by system as far as system is. There is one way it is acceptable, or there is no, it's not acceptable, or it's partly acceptable, or it's not partly acceptable as well. And we have to think about that. I'm just giving you some talk on quality, coordination, very preliminary talk, because it links to this file, and this file is for, you can say, this for quality. Quality in open terms. We have to be very smart to understand such activities, such works, because works quality cannot be compromised. That is our determination. We cannot compromise on quality, and if we compromise on quality, I do not consider those people responsible, because you just want to do something without having any objective. So we cannot compromise just in name of system. That we are only interested in formality, and we don't want to accept anything else. That's not acceptable. Only point is that whatever work we do, it should not fail. It should not fail, it should return in its successful delivery. Work means delivery. Delivery of is being conducted or being done. And that is very significant point here. If this point we understand, we can understand a lot. I'll not concentrate on this file currently because I have talked many times and I have not made some amendments to this. Only that you can see red line to be resolved. Now this red line is different line. It's not red line is talk on works, but that's also same. That red line is in works and this red line is our individuality or in our approach, how we conduct something, how we work on that system. So we say there are red lines. Somewhere we have to identify. There will be red lines somewhere based on some conflicts which you have to write in. That's why we say it's called red line markup. And that red line markup we have to first find which is red line. Where is this markup, and if the access to find is a problem exists, we have to resolve it, and that's our duty, resolving red lines or resolving errors or deviations. You can say if you can resolve, it's fine. Then we can incorporate that answer onto our engineering professional activity. And if you cannot analyze that, there is no way you can move further. Because this is first fall in your system. You cannot move further if there is an error beyond tolerance. And then we have to think of how to permanently solve this issue. And that's what we can say, all complete engineering world. Say certain red lines that must be turned green, and you can say that must be a must. We've gone through many times this. Can we not apply quality standards complied with overseas? How work is done there? If we recognize that or if we appreciate that, and we compare to how we do, we'll find a lot of difference. But I'm not saying whatever done is overseas, okay, I'm not saying that also. But how much you are with this client, you have to compare with others. That's the only way that you can know where do you stand. We can say we can work in coordination. That is, this is a presumption. We have to work in coordination on all activities whatsoever to achieve defined or expected quality profile on works. And if we are unable to do that due to whatever reason, then it's our duty to revisit quality required specifications or what we have been doing or how we have been performing, or there is something that should be available but is missing. Why should we not revisit? That's another question. What is the reason behind that? Have to think on that also. And why should we not apply coordination requirement on our works first? And you think it's a must or not must? Anyway. And really, we have certainly worsening state of quality of works, and how to improve such mandated works quality to certain minimum required marks. All these points are very significant, and we have to take them into our contemplation, into our, can say, consideration, and we jump onto this file now currently for further studies, and those are not academics. This is not academic study, but this is a work study, practical study, or you can say continuous professional development study, which is much more important than academics only. Because here we understand facts, we understand how to deal with resources, how to deal with technology. But in formal studies, we only keep ourselves confined to sorry, confined to program syllabus. But here syllabus is limitless, and here we are not bound by formula, or that you have to think this way, or we can say this is way, or this is a principle of solving this. In our practical world, in our engineering professional studies, we can say, I'm saying professional studies, not tech studies. So many ways we can think. Here no, you can say binding, but you have to think. Here you have to think your way. You have to think best way. We have to find our ways out for solutions from existing issues, from problems that otherwise would not be possible to be charted out for solutions. And that's the reason I call it by name coordination engineering, which is very specific term in engineering itself as well as in life. In life we call it coordination, and in engineering world we can call it coordination engineering, and that's on projects. And engineers have to operate coordination system, and this system also engineer has to operate and to design before operation. It's nothing, means it's not physical, it's mind work. How do you move our activities related to works? Very significant point of view. And coordination engineering is not always same. It varies its definition from time to time, from point to point, from requirement to requirement. Sometimes it's very helpful, and we can say for reliable quality engineering works, deliverables. It's just a note, just a very brief note. It's not final answer, but every day we keep on thinking how to make it better, further better, and further better likewise. So therefore it's very much a realistic issue in world of engineering, cannot do otherwise. We have conferred on certain projects, and we will keep conferring on them, because those are references. But we have to move in rapid way first to understand how to know about it. These plates which are shown to you are only few, not all, just for reference. And what was done there, that is already discussed, that's already been discussed, yet will continue to be discussed. But now where we go to get some deliberation, conduct some deliberation on, you can say, on coordination engineering, and we call is a must on every project. It's a must, and there can be nothing else. Is right enough, we call that way. We cannot say that's a joke. And I just read few lines every day to remind what we want to say. And those lines can never be forgotten. We have to, you can consider these are principal lines, though there's no definition as such, but just keeping in view, how can this be done? And that says designs, construction and controls are very interrelated requirements to achieve successful start to completion of a project. And whatever we do, all that must be applicable throughout project stages, with all works be smoothly effective. Designs may be considered oversafe or optimum, but real construction involves actual expenses we have to keep in mind. Contract time we have to keep in mind. Financial liabilities and buildings professional reputation. We have a certain motto, we have objective within an organization to apply good controls on all activities or on projects, so that we can keep in line to schedule, that is plan. Being an actual part of controls, at least time control, we can say cost control later on, but first of all we have to move in time, which is very significant part of contract. And we can say control includes progress, cost escalation, time, budget, quality requirement or assurance, coordination, engineering as well as total engineering, along with safety, risk covers and delays recoveries. All these we call controls, and it controls means controls on progress, control on cost assessment and cost expenditure. Then we have to see what meaning of time, how it acts, how it responds. Time very important part of works, and also what budget do we have. We can extend it, we can bring more budget, or we may say quality requirement assurance or promise. And say coordination, engineering as well as total engineering, and safety risks covering and delays recoveries. So many points are written here, so many points, and these points are not futile, these points are pressure one. If we don't intensify them, we can lose our points. Very important points are, of course, we have understood progress is very important one. Our progress should move on and on. Otherwise, we lose every progress curve we redefine and time is wasted. We can say S curve type situation. S curve means it should work, and we have to finish this curve also one day if it works well. We can say these are all integrated divisions which should now move in unison to achieve project deliveries. Ultimate, what we have to do, we have to deliver or we have to dispose of after getting input or after getting prepared product from vendor self. All these divisions should, we can say, when product passes, it travels through all these divisions and then it leads to some location of rest. These integrated divisions, these move in unison to achieve project delivery targets. A well-designed project we have to think of a well-designed project could be jeopardized. Well, I know your meaning of jeopardized. A well-designed project could be jeopardized during construction phase. During construction phase, from budgetary viewpoint, should it not be given due required controls application properly. It's very significant part when we work in team or we have some guests. It's our duty to keep those guests safe, and particularly when we think that we are falling somewhere. Well, this personnel should be brought into use for whatever purpose they have been employed. We can say, if you don't care for designs, if you don't think of construction issues in advance, in your consideration, we can say that we are not engineers, we are not engineering professionals. Because if design is excellent, designer has put its full force into this production, but at the other hand, in construction, everybody cannot be responsible. It's also true. Without organizing full intensities, keeping eagle eyes on projects and construction controls, no project can be delivered in time and fixed budget. So we can say also, if quality is missed, then there can be questions on project, that how this has been carried out, what is its claimed performance, and also we cannot generalize issues of public. But public has to think of its issue, because that issue cannot be solved at the usual, you can say, level of ordinary requirement. We have to think again and again, I can say. Engineering never cheats you, engineering can never deceive you, we deceive ourselves. We have to be very serious in this. It's duty of every project leader, project manager or construction manager, while saying project leader. It's duty of every project leader must get allotted budget, and then to move project within its defined ambit. And we have to remember that once money is lost, there remains no possibility that money should come back. It's gone, it's gone. And engineers don't allow it to go easily. That's an important point. Now, we say project leaders must be entrusted, must be responsible for budget that has been allotted. Is it worth or not? It's worth or it's not worth. It's capable or not capable. And then to move project within its defined ambit. And we have to remember that money lost cannot be regained. And it is very, you can say, simple statement. That we cannot lose works, because losing works means losing all resources. Losing all resources. That should not happen. They should not find time. They have to worry all time. Therefore, money has to be preserved, material has to be preserved. Analysis tool can be required to operate with complete dedication to carry out or conduct controls. When I say control is very significant term, much more significant than Suman or whatever it is. Analytical tool can be required to operate with complete dedication to carry out or conduct controls. All required sections, related activities, import total dedication from quality input within such disciplines in actions as well as in works. Whereas all such acts certainly demand involvement of engineering coordination activities at each and every ongoing detailing review and to ensure constructability issues. Constructability is very specific term. Its meaning is clear that whatever we do, it should be based on specific construction, and whatever we deliver to ourselves, it should be constructability, or we also can say buildability. Whatever we have to build that, or we have to charge that in terms of smaller units, smaller items. And we can say all required sections, related activities, import, total deduction, total dedication from quality viewpoint within such disciplines in actions as well as in works. Whereas all such acts certainly demand involvement of engineering coordination activities at each other and every ongoing detailing review and to ensure constructability issues. It's fully charged. Let me put down battery of this for a while and then we see again how we handle this, because fully charged battery. Let me put it down. Now, I am very specifically interested in involving my friends, my colleagues, just to come out of your specific discipline or in particular designs. I am specifically talking to engineering community in this way, that you have to come out of this issue of that you are only in designs. I know design is very important, and without this we cannot work. That's also true, because design has to be implemented also. That might we must keep in view. If design cannot be implemented in a way which is required, in that case we can say there's no meaning of design if we can't do that. If we can't implement that. Implementation is very much. And if it can be implemented in a proper way, in a professional way, or you can say in the right way, there is no way that we can achieve quality with success. And it's not, design is just the start, you can say. Design is just the start of works. It's not end. And every design is not perfect. There can be many designs of same requirement, just like there can be many methods of construction for one activity. And it depends on choice, or you can say calculated determination, designer, what to adopt and what not to adopt. Very significant. What do you say? All required sections, related activities, import total dedication from quality input within such disciplines in actions as well as in works, whereas all such acts certainly demand involvement of engineering coordination activities at each and every ongoing detailing review and to ensure constructability issue. Constructability issue is very significant for everybody. It can be plainly said that engineering coordination is an only formula or discipline to reach workable, consistent, and competent solutions to achieve successful performance of every activity to be conducted to avoid possible delays. What's the reason that I am stressing on coordination and constructability? If we compare these two terms, constructability or we can call it buildability, as well as what is, you may say, coordination. Coordination is like, you can say, many requirements coming together, many information coming together, and we have to keep them flow together by our own operation. Even if one information is ignored, it can cause problems, very many problems. And same way, we also can say that here is coordination and there is constructability, buildability. This means construction ability. We design something, we have to construct that, and that constructed must work somewhere. It should suffer, it should give service. So if our information on papers or in whatever forms where we instruct others, that information should be strong enough, should be fully potential, should be potent to provide information which can be called construction-able information. And this information we are going to use is easily constructed, can be constructed without facing any encounters or some problems. That's construction ability means capability of construction and efficient construction, not just construction that in 24 hours I do something. No, this is what we can say. Constructability is very important point, and our quality system that we operate should support it. Our quality system should have supported, safety systems to support it, and on top of that our mind system should support it. For all these issues of coordination, organization, and we have to deliberate depending on reality, not just assumption. When we deliberate about this, we will find many terms as we were discussing last time. These terms, and we had gone through many. I don't want to repeat all this. We'll again repeat some time, but I'm interested to confer on those terms which were important for us. And we have been going. I'll go fast by using this page, not just stay here. I'll go back. This was some here last time. We added something Ravan. Here is I think this requirement. Let's start here. It says say foregoing major paragraphs. Okay. Okay, said here. Let us see. So here is now, I think, point number 78. We have taken some points last time, but no issue. We can just go on refreshing and overlapping. It's all these included works mentioned activities amount to involvement of engineering and coordination on equal basis. On equal basis, that is coordination and engineering. Because if one is missed, if say engineering is missed, there is no meaning of coordination. If coordination missed, the engineering misses as well. Because one is missed, other shall also miss. That's true. One depends on others. These are not independent one. We cannot take out state of coordination and say, okay, engineering will move. Engineering will move, but in fragments. It won't move its unit or unity or item. So we say all these that we discussed previous one, these involve importing engineering and coordination ways on equal basis because of one is missed. If one is missed, other shall also miss. Which criticality, you can call it criticality also, which criticality must be considered seriously for smooth, for reliable documentation, for reliable working. When we say reliable means working is also reliable, or execution of project works. It's again refreshed. We say refreshed, we are using certain terms. It's again refreshed that conducting multidisciplinary coordination from involved branches of various engineering that must be depending on project nature shall always be a must for final detailing out engineering solutions and not just working on isolated solutions for each discipline. So this is very important message. Again I read, refresh that conducting multidisciplinary coordination from involved branches of various engineering that must be depending on project nature always be a must for final detailing out engineering solutions, not just working on isolated solutions for each discipline. This requirement is often missed by many juniors or budding professionals due to lack of proper project experience. But once one gets itself certain project delivered, then considerable lot learning is attained. That is very important part. If you experience some project in your career which you must, or you may say you have opportunity to get that, and if you get that opportunity, you should not miss that opportunity. That's also a requirement, an intellectualism requirement, a professional requirement. You can convert these products to your quality products, but these should be applied, these should be delivered. So we say every junior or budding who swear requirements often missed by such young people, young engineers, but it should not be missed. It should not be missed due to it misses lack due to project experience. You don't have project experience, but you get experience, exposure to projects. Once gets missed itself, certain project delivered, then considerable lot learning is of course attained. If you deliver a project in full-fledged state, of course in whatever position, next project shall be easy for you for handling, for construction, and that is what we expect is right. Only reason that after having undergone few years of working experience on certain projects, one can call self a trainer to oneself. It happens, it happens oneself. Confidence, oneself confidence, where after such confidence acts as one of competency potentials. Each and every such competency or competencies counts while considering professional attainment, marking as part of continuous professional development. It's very understandable if a blind sex that until you are in job, you never care about what should be done. It was just sometimes setback that you get admission. Well, it doesn't matter, then we have to say only reason that after having undergone few years of experience on certain projects one can call self a trainer, means you become your own trainer. It's very important point. If you can train yourself, there's no parallel, there's no equal to that. You have to make up your knowledge, make up your mind, and you have to make up somewhere. There is now I say that one can call self a trainer to oneself, and then trainers towards others, which wealth earns oneself confidence what we're after. Such confidence acts as one or such confidence is very significant, and it can force people each and every such competency or competencies counts while considering professional development. You may say professional development attainment, or you may say whatever else. Continuous professional development is in such useful engineering grooming up situation. In such useful and engineering grooming up situation that makes projects to act like a field university, which is an important point to keep in mind. I'm saying field university, it's not the university of education. We are calling it university of learning without any resource, without any reference. And we can learn from books as well as we can learn from experience. But we should try first ourselves, and if we fail, you can try for one session. If you fail because you're not ready to face examination, then that was another issue. But it says that if we can say such grooming up we have to do. This is called grooming up situation that makes projects to act like field universities, though no academic short-term title is conferred on such university or degrees, etc. Yet there exists no alternative to replace such reliable training from elsewhere, and not only here, everywhere around the world, and particularly in civil construction works. It's not possible because we don't have free materials delivery in market. There's no such market which can shop your projects. So we can say that it's a very important point. You have to understand that this training is extraordinary always. Maybe this is no technical title, but you have confidence earning your knowledge, and you have every property that should be very professional. And this means professional if you learn more and more, because professional itself says it's a parallel study of whatever is ongoing. We have to know more and more from existing technologies. We have to know more and more from all this information. That's a very important point. And otherwise we can say we waste time if we cannot learn in field. Learning in field means real learning, experience-based learning, information-based learning, as to knowing how to handle situation, how to learn, how to understand people, how to understand whatever you learned in your university, because theoretically they cannot change. Yes, working methods can be changed, sequences can be changed, but basics cannot be changed. We have to keep that also in mind. So I consider every project as added qualification, added name of work, and every work is having many years of contracts performance. So it can be said that for a couple of years, even for 6 months or 1 year, you stay on some project, and that project is good one. There's some system operating. We can say that we learn a lot because you see practical every afternoon. You see seniors there. You see machines there. You see responsibilities there. How work is done. How to keep site tidy. How to understand health of people. How to cooperate with them. How to inform them. How to use them. All this is very important. It's not that only design is engineering. All such activities are engineering related and engineering. We have to be very careful about that. Knowledge has no end, we know. Knowledge is unlimited. But as far as work is concerned, we have to apply some knowledge and some limits. We cannot say, now we have done this, last time we'll do that. That's not applicable also, except in maintenance. So we can say that since because such projects release the organizations equips incumbent professionals with certain permanent knowledge along with sharing responsibilities, and such chain continues throughout work career of professionals. And that point we have to understand, keep in mind. Very important point is that. And if you don't do that, we certainly miss a lot. Also on explanation last time of various documents used in engineering, as it says, now we have to say that since this page is exclusively related to coordination activities that are always involved on engineering decision making, without which support progress cannot move. It cannot be achieved, rather we should say. Such requirement imports very significant, and you can say import significance in necessity of certain reliable professionals having multi-facet theoretical and practical and various callings. And even if one has a deficiency in certain discipline, documents reading would make up that deficiency virtually. And that's also very important message, that reading is also must in continuation to working physically on sites or in designs. You have to keep learning from whatever reliable source or experience-based source, or whatever libraries do we have in our institutions or organizations. So we can say again, it's also a certain fact that coordination is an individual scrutiny oriented without requiring any interruption to enable incumbent coordinator to concentrate continuously for whatsoever or whatever issue until resolution reaches for clarification and confirmation, and for certain possible propositions, whatever suits best in project interest. So we cannot just avoid that. We may avoid if we do not know terminology, but here we know we have sequences, we have roles, we have explanations. What should be done, should not be done. That's also a very important point. So again, it's also certain facts. You cannot run away from facts. Facts that coordination is an individual scrutiny, of course, oriented one without requiring any interruption to enable incumbent coordinator to concentrate continuously for whatever issue until resolution reaches for clarification, or we obtain clarification or confirmation for something to be done, which way to be done, and for certain possible proposition. Whatever suits best is is in project interest. We have many documents. We use many documents can be used and are used on many projects, such as we have named here something, but these are not end, just for reference it's done, and I have searched it also. If you can get more, if so required, can be added to these, no problem. Most people associate a criteria for works with drawings and specifications. Although these are likely to be most significant sources of information, nevertheless, there are others, and it is important to consider all such documents, drawings and specifications often refer to and require compliance with other documentations or other documents, namely a specification for concrete may refer to National Structural Concrete Specification or else. Therefore, these following points may be a list of relevant items to consider. Although this is not exhaustive but indicative and brief, and it is, we can say, drawings including notes on drawings. When we say drawings, it itself is a very wide world on every project which involves drawings from all engineering disciplines. So we can say drawings, and it says notes on drawings or whatever else, tabulations, schedule. These are all significant. We have to know them. We can't just open all drawings sometime, but at least having first look study is very important, because what we want. Then we have design specifications. When you say drawings, means drawings from all disciplines. And these drawings from all disciplines, if these are available, there are a lot of information, reliable information or not reliable information. We have to question ourselves. Even we sit together with others, doesn't matter. We have to understand that drawings are of all classes. You can say site or key plan, and we can go through all disciplinary drawings separately, and also journals. We have to get this point. Say design specifications and drawings are clubbed together, because specification should be correct, it should be hot-minded, it should not be reasonable. Design specifications is not limited. We have various designs and various detailings, and this is what we have to think about, as it says, whether structural behavior. We have to consider design specifications, very prominent documents. There are various design specifications for every project and covering all items. It's a good feedback. Um, uh, uh, We have to keep in mind the specifications which are prominent design systems, indirect designs. One design is there, then there is another design, reflective design, or there is secondary design. The first is cow design. That is cow design consideration is the first requirement, and then comes we have to understand specifications first before doing a job. But how many do we understand? We say it's none. It's been ongoing since since you can say start of specifications or start of materials. When materials first started, they don't know what's the meaning of those. Uh, then we have to see about many design specifications, manufacturer specifications, particular specification, general specification, and many more writings. If you really recognize our errors. Then we can say after that list we have in that sequence we have standards, various standards. You can say British or European, international, others, various standards. Like you have to understand that, and you have specifications as well in that, and various other networks, net standards, national structural concrete specification, maintenance requirement, contract requirements, planning conditions, building control requirements, National Housing Building Council requirements, legislative requirements, lessons learned workshops. This is a very, very important one for purpose of explanations and letting you know what we're talking about. And that's what you say, like something improvising at time of writing. If you don't refer to some other writings, I think you expose yourself how it is done. So we can say, we say as the drawings specifications and standards. There can be no explanation of standards because it's up to you or your nation which standards follow with. And of course, our country's name is absent everywhere. This point we have to clearly understand that what shopping we do, design specifications, British, European standards, other standards, national security structural concrete specification, which is very, very important here. From each point of view, other standards, you know, if you don't know, you can open and read, and you require that. That's up to you. I've seen today that at my wife didn't do that. They didn't do the woman, and my wife has held that. Can say therefore national standards, national specifications must be understood first, and we have to see other specifications, and which is a combination of all and more variable. We can adopt that, we can afford that only. Manufacturer's requirements is very significant part of specifications, because we are sometimes not determined to know that how it's working, what reason exists that yes President allows such specifications in our India. And that's what I say. In this way, we can say when you say manufacturers' recommendations, requirements, or manufacturers' processes, we have to concentrate on them, because we are going to use respective materials, and first those 30 years experience have taught us what we could not learn from this group of people. Let's go to now some requirements of manufacturer, which are very important ones and which must be complied with. And we may start those if not complied. Manufacturers would claim that you did not follow my instructions, although everything is beyond my control, it's in your control. That, a world of avoidance of responsibility, I can call it. If you don't want to have education, how can you maintain your CPD? Really sad. And if some seniors visit some offices, some companies, and find that some requirements are missing for this. It will be very serious about that. Manufacturer's requirements can't be taken for granted. These are important, must be done accordingly. And this word outside. We have to be off local limits. To off that, Manufacturers' recommendations are based on results, based on scope of applications that can be used on such activities. And we must say manufacturer's recommendation is also a way to acquaint yourself with such possible issues. So we may say manufacturer recommendations wherever it is given, and if you employ this formula, point is, these recommendations are always having significance, particularly when we receive these documents. We have to keep this point in our mind all the time. We cannot just run away from this fact, and if we run away from this fact, since we run away from reality, and that reality is a very important one, manufacturer's requirements, we may start. You can just think of how it can be done. It's very important one from processing viewpoint, from every viewpoint. We can just think of how we do it, by whatever way we can say. We can say, if we say, how does it define that we have to see? Manufacturer's instructions, written directions provided by manufacturer or distributor of a product that contains the necessary information for safe and effective use of product. We may say that, and there is a manufacturing instruction definition, in fact, that we can say. It's a very important point. We have to understand, we are not serious about that. I may say manufacturer's information means manufacturing instruction prepared by parties on behalf of general mark for manufacture of products, as same may be amended from time to time by written agreement of parties during term of this agreement, may say manufacturer has to decide what is that, how to do it, and manufacturing instructions means those manufacturing, packaging and labeling specifications for products used by or on behalf of a seller or whosoever affiliate of whatever stage seller in corporation or the seller in production and supply of products, including formulae and materials that are reasonably required and are used for manufacturer quality control, release, stability, or period of thorough input. Means that something very, very important definition. When I say manufacturer's instructions means those manufacturing, packaging and labeling specifications for products used by one or on behalf of a seller or whatever institution that and drawing. I can say products including formula and materials that are reasonably required or used in manufacture, quality control, release and stability testing of products by or on behalf of seller or whosoever affiliate of any seller immediately prior to closing. In a sentence we can say an example of manufacturing instruction in a sentence. Sample requirement sampling inspection is allowed except for mandatory inspection criteria, and key characteristics noted on engineering definitions are if we can say engineering definition, if otherwise is specified in purchase order, engineering definition or special manufacturing instructions. Such procedures should be provided in master manufacturing instructions for each product. Smaller advanced delivery variants is totaling whatever it is we have sought. It's some example of project I'm just giving you. Now, if articles are manufactured otherwise, then in accordance with data supplied in technical inquiry form or not in accordance with manufacturer's instructions or technical data sheet, Symphony shall have no liability, which says something like that, it's a manufacturer's claim. Here we say, you can say that more definitions of manufacturer's instructions, products protocols, we say production protocol, and all amended thereto for manufacturing of product as agreed upon between parties, means those manufacturing, packaging and labeling specifications for products used by sellers or sellers affiliates in production and supply of products. And also we can say manufacturing instructions, that is document completed by whosoever, left by customer, which defines manufacturing methods, test methods and other procedures, directions and controls associated with manufacture and testing of products. It also means those manufacturing packages and labeling specifications for products used in business and proposed production and supply of products, including formulae and materials such seller. So seller party is reasonably required to do, then we can say many more such definitions are available, and we cannot just, you may say here, so many definitions are given, but important is that some not trade secret, some not, but in general is very important. So long list is there, and I'm not interested in that, but we just want to know what public thinks, what manufacturers think. And there is a law insider, it was now. There's other issues, manufacturers' instructions, health and safety and work. It's also very important part. I can say health and safety at work. Then writing standard work instructions for manufacturing. Let's say first of all, this writing instructions for construction for manufacturing is the latest one here. Writing standard work instructions for manufacturing. Says there's some page here, and this is it says, for example, it says, over years I have visited hundreds of Chinese factories, but I rarely see good manufacturing work instructions at disposal of production operators. You can say maintenance technicians and quality inspectors. So rarely see good manufacturing work instructions. Then if with new product introduction, engineers haven't prepared a standard work instruction sheet already, you'll need to start writing them up. When writing your manufacturing procedures, you should follow the 6 principles outlined below to ensure that your instructions are easy to follow. Standardized work, number 2 is write with people who do work every day and get employee buy-in, and also visualize standard work instructions, and they say include other elements. So let's see this page, if we can show to everybody. We can use this for our understanding, and let's see how it works. You can print it out and show to you. It's a good one. We have to think of how nations work, and how it can be properly done. The best way to understand, and it can be said that's a good example of that requirement. So we said, let's take this. So examples should be given clearly for every response by manufacturer. It is coming, and I think it will come soon. It's to come, however. So it has come, and it is like this. You can say it's both writing a standard, what you're saying is writing, and that is standardized work. Number 1 is standardized work. Very important point. It is standardized work. Core idea behind manufacturing instructions is to follow one's best way currently known in this organization, so that if 5 people work on a particular job, they do it in the same way. If every operator has its own processes, it can make improving way. They work quite difficult. By following standard manufacturing processes, one improvement to work instructions can be can be applied immediately across board and increase productivity, quality and safety. So that's called standardized work. Before standardizing process, think of ways to simplify each step. If if one can set up fixtures, gauges and other tools to make work easier to do, it's a huge win. If you have to engineering resources, do that now, don't delay it. So standardized work, whatever work you do, avoid write it with people who do work every day. Write it with people who do work every day. It's also a very important point, means you have to seek information. It says people involved in manufacturing process. People involved in manufacturing process. Let me see, percentage left. People involved in manufacturing process day in and day out often know how to do a better job than most engineers sitting in your offices. Might not try to do a good job in certain instances. For example, when they are paid by piece and never have to do rework on mess they have made. But usually they know how to do it. Why not pull them out of production for an hour and work together to determine optimal manufacturing process? It not only gives you a better insight into procedures, but it also trains. It also trains, you can say, them think in a better way. I know maybe well keep thinking of it. To use mind in a week, they may think a better process. Should, we have so many ways. Get employee buy-in, you can say. Get employee buy-in. Chinese factories treat their low-level employee as disposable. That's not acceptable. And then also, don't fall into trap getting your employees' feedback. All right. Now, involving workers and writing work instructions leads to sustainable improvement, as you can say. Even if they disagree with an aspect, it will give them an opportunity to I think missing a problem. So visual standard work specification instructions. Once work instructions are written up, this need be enforced. A leader or supervisor needs to be able to walk around and identify at a quick glance if standards are being followed. Drawings can reflect manufacturing instructions much better than text paragraphs. I have seen many work instruction sheets written on bland templates with no graphic element to visualize manufacturing process, and unsurprisingly nobody reads them. Unsurprisingly it happens. This writing is not much helpful. Drawings, pictures and when possible videos are much more likely to be followed by operators. Think along line of instructions manuals. We can say in that case include other elements. When people think of standard work instructions, they think of a work sequence first to do this, next to do that. Having this is quite useful, especially if also includes material movement and transformation as well as inspection and testing activities. But that's not only way your manufacturing work instructions should encompass. Try to include a standard timing about how long is a particular process supposed to take to keep line balanced. It should not be used to penalize workers or single out those who are too slow. Rather should put some healthy pressure and indicate who needs specialized training. In lean organizations, try to get as close as possible to one piece. So we can say there are so many shoes. Example of real work instruction sheet from global automatic supplier. Stavan, so instruction sheet. And it's okay now. We have to see what about that. Here is, manufacturing. Well, train your progress. Train your process engineers. Do you want to develop your junior engineers? You can get them to work on projects to increase productivity based on work instructions and other data they gather. Developing a certain, you can get them work on projects to increase productivity based on work instructions and other data they have gathered. Developing a combination table is useful when you want to go deep into data. So that's also important one, and we have to see. So there's so many. Another great tool is process chart. This is a process chart you can see, and we can just give sequence of this. Another greater tool is a process chart to show about how balanced and unbalanced production line is. These two charts are good starting points for analysis of what changes will gain productivity. The first thing need is to have is write up First thing you all need to do is write a standard construction sheet. Don't skip this step or delay it, as it's often one of first priority to ensure a certain quality level. I've got positive and negative experiences with writing work. With writing work, you can say instructions to see them as an essential element or as decoration for auditors and customers. Let's know now. Okay, this is something different. I'm not interested. Okay, we'll take this down and go back to some other work. We search now for another file, and we can start. This is manufacturer's instructions, writing standard work instructions are there. Also, why is important to read and follow manufacturer's instructions? It's also certain, I think, good one. Let's read something we get. No, let me see. I think it's not very descriptive. It's waste of time. Leave it. Now, what's important? Follow instructions. Why is it important? let's reference.com and let's see what it says. It says something now, let me be clear. Why is it important to follow manufacturer's instructions? It says how best use. It says important to read industrial instructional guides provided by manufacturer in order to understand how to best use product features. Manufacturer's instructions contain specific details. Product details about product that are not readily available anywhere else. Manuals and guides inform consumers about product specifications. They may also include assembly instructions. Without this information, consumers may not understand how properly assembly So it says important to read instructions guides provided by manufacturer in order to understand how to best use product criteria. Manufacturer's instructions contain specific details. Specific details about product to its interest. Oh, as I said that it's important to read instructions, and also we say manufacturer's instructions contain specific details about the product that are not available anywhere else. Manuals and guides inform consumers about product specifications and may also include assembly instructions. Without this information, consumers may not understand how to properly assemble or operate a product. We can say product instructions include important details about product setup, installation, Let me put on switch of my battery. say, may put out the instructions include important details about product startup installations, and consumer should read these guidelines in full to ensure product operates as intended. Consumer can typically find troubleshooting questions and answers in product instructions should problems arise. Manufacturers expect consumers to follow instructions provided. If a consumer damages a product and did not follow instructions, product warranty may be voided. Safety is another critical factor. Safety is another critical factor to consider. Product guidelines contain important safety information that helps purchasers avoid personal injury and property damage. Consumer Reports recommends reading product manuals before making a purchase. Manufacturers post product guides online that can be downloaded for free. Consumers can get an idea of how product functions as well as special requirements needed for operation, and that is also an important point. So we can go back and find something else important. We say manufacturing work instructions, definitions. What does it say? That's also, let us see. It's not much given here. Manufacturer's work instructions refers to instructions or procedures that guide manufacturing teams to accurately build, package, label, and ship products to required specifications. Having clear and accurate manufacturing work instructions, is critical to avoid production mistakes, quality issues, scrap rework, and customer satisfactions. And we can say another one. Just trying to find good definition that can be shared with you. So what's important to follow manufacturing instructions? Leave it is also not that much capacity. We try to share only valid information, not just, let's see if we go next page, if we find something, maybe instruction books and instruction manuals, owner's manuals, compliance with manufacturing instructions. I don't think very important here. It's not. So you can say, okay, you find something here in our text that we are interested in. In our text we are interested in here, and we just said that manufacturer's requirements, manufacturer's instructions have gone a long way, and also contract requirements. That's another point I have to concentrate. In addition to manufacturer's requirements, we have gone through so far. In details, we have gone through here. That is, if you say it's not moving, let's see how. We may say that manufacturer's requirement we have gone through so far. We have gone through here. Drawings, design specifications, standards, other standards, national structural specifications, manufacturer's requirements, contract requirements, manufacturer requirement, contract requirements. Now contract requirements, you know well what's that means. In contract we define every requirement, but that is not directed towards manufacturer's requirement. That is general and specific requirement which must be satisfied with, and we have to refer to those products which come into our explanations, our definitions. It may be general one or it may be specific one. If it's a general one, then we can define what should be specification, what sort of material it should be, what should be its properties, maybe how it is manufactured, and how shall it work, what shall be its future response. Likewise, in our specifications, contract specifications, all these are generally covered. If it is general, and we can write specifications about the generality, and if it is particularly different, then we have to give that explanation, and if it's not possible, then we have to include this requirement in certain list of manufacturers or list of materials, and that material may come from whatever manufacturing units, but it must have all those properties. And if it's named, it's okay. If it's not named, doesn't matter. Then every property must be studied. It must be understood, and that must be complied with. And therefore, the specifications also speak same. This speaks same. This material should be like this, or we can refer to other document where you can find more. So comprehensively, you can say that contract must speak about every material. Otherwise, there is no meaning of contract. If you leave it to contractors, then you can say you don't know the profession, you don't know how to bind contractors. So that is what contract requirements. There could be many requirements in contract itself, and each requirement must talk to each other. Clashes to provide the gaps between two, and sometimes we have to keep in mind which manufacturer is responsible for this you can say closure of or whatever you can say we use for those materials. These materials can be food articles, this can be machines. We go then to planning conditions, which are planning conditions or programming conditions whatsoever. And building control requirements. You know that building control requirements, not one, not two. There are bylaws, by regulations, maybe others. We can say building control requirements. Building control requirements, we can just find to see how this works. These building control requirements, let us see. What does it say? Building regulations, these are, you know very well what I mean by that. Buildings regulations, whatever bylaws, national building laws, all these are building controls. So no problem for that, we understand that one. So building control requirements, housing buildings, national housing buildings, control council requirements, it depends on every nation. Legislative requirements and lessons learned, workshops, business management system of sample and benchmark. Here we can say go points and building control requirements. People have to know what's required, how can it be done. It's not only those planned but also otherwise those who practically involved in field. That is, these codes, these are all points that are related. Then comes to housing council of area. This also must be bound with something, and ultimately legislative requirement. That is important, is legislative requirement, what legislation says. That also we have to see in whatever area. All these points must be in care of engineer. And then lessons learned, actually also, that's a history, but very important history if organizations has that written document with them, and that can be set for future future, you can say, of this world. That is, lessons learned is so important that if we again make mistakes, then we can say that we are foolish people. Once mistake you do, it's okay, fine, I made one mistake, but that should not be repeated, and that cannot be repeated if we investigate how this mistake was done, what points are missing, and we have to keep that in mind. And we have to act in future. If that happens, we should not forget that. And there is the workshops. Workshops are done for every new act or for every specific application, and their workshop must be respected well. Workshops, then business management system, samples and we can say it's again stop moving. Let me see what's problem is there. Okay, so business management sample, and then we have these are a few points. Workshops is not new thing. We know workshop. We have to demonstrate, we have to teach, we have to train our people for particular work that is to be done. And we can say workshops, we may say. And business management system, is different, and business management system of organization, sample and benchmarks. Now we can cite direct use documents for day-to-day purpose. I'm naming this site direct use documents because every day this is used, on some parts, others, and we discussed last time also about this. We discussed about site memorandum, we discussed about site instructions, also engineer's instructions, site technical queries, engineering queries, construction method statements, and also shop drawings for work execution. So we can say then, let's read one. That's where it's very important to discuss with, to hold it in discussion. And let me see if I can blow it more. Oh, no, it won't blow up more. Let's go as it is. So site diary or daily job records, call it report, that must include activities completed, activities planned. I can say works and plans, system plans. We can say report that must include completed activities, planned activities, worker strength, supervision strength, weather data, equipment arrived and equipment left, progress advanced or is received, achieved status of materials arrived, visitors on site, quality issues, specific actions, safety issues, etc., and whatever be in particular required or transpired and participated. Now, what these contents actually state about that point, we have to see. We have to see and understand that. We must have an understanding of what actually we want to say, because it is site diary and it's daily record, that what happened on site is briefly included in that. If included in that for reference in future, because we shall have diary per day or page per day. and it should give certain information which are of necessary requirement in terms of resources, in terms of work, progress, in terms of weather, and in terms of stocks on site, and what sort of people coming and starting doing. That's more important. So we may say what we need, we require is what? We required that till yesterday what activities were completed so that we know where is project standing, where is progress standing, where does it stand. Is it on line or it's not line? An indication comes from there. Then we can say what activities are completed and what are planned to be completed. So there is a gap. What completed? That is confirmed answer. What is planned in future, and we expect possibility that these activities shall be completed in this frequent period. We say what activities do we plan now? That's also important. What activities do we plan? Because planning depends on further work or works completed. Those activities should be clear and should be taken care of, keeping in view short time of every day. And then of course when we should know how many workers do we have. How many workers do we have, and we have to know also what strength tenders have got. That is a different issue. So we have to think on this daily job record, as we said that we have to make sure worker strength and what worker strength we have today in class wise in all categories, is that enough sufficient to keep these activities continue, or we have reduced the strength. That point is very important. We cannot open all activities if strength is lower, and for 1 day or 2 day work it's not useful to get out of workers and meet additional criteria. So next point that we can continue here is worker strength is very important. Worker strength shall decide whether or not we can move further on that activity we planned for, or we have to curtail down some activity, or we have to replace some activity depending on situation on site. There are always chances 2 or 3% people missing, or some may be sick if not missing or not. Because they may not be absent, but they may be off track, they may be resting. After all, humanity we have to think, and we have to think of supervision strength because of requirement. We have people, but no supervisors, and we can't expect these people. They use many equipment and also materials. So supervision is a must. We can say responsible supervision. That's a point where you can say supervision strength must be available. If you have full strength of workers planned, and if shortage of the strength, we have to think of how to do that. Means that weather conditions, weather data every day is important, and it's better if you write at least twice or sometime. That is temperature difference, temperatures, humidity, not at least temperature must be there, or because of works temperature is relevant. How about only concrete temperature in that case, likewise. So weather data is important, and it can be collected very easily. There's no special requirement, only experience. We can say method of everybody can know temperature, etc. And equipment arrived means equipment where not small tools but major equipment. When it comes to site, it comes to site work, and it goes from site outside and it acts reverse. So this is what we say. Then we see equipment arrived and equipment required. Then progress advanced or issue, that also we have to make sure. It's not just we have resources should work also. So what work do we do? What did we do that day? Approximately that should be reflected in all these pages. Facebook. It should be there. We have to be very careful about. So we can say like progress achieved, status of materials, you can say arrived visitors to site, quality, you can say issues, and specific actions, safety issues, etc., whether we in particular required or trapped on their particular type. So these are few points which must be covered, and there can be additional points. There can be some issues related to quality, maybe written in this, some issues related to safety, all are written. And if you give in writing, it's a better point. It's just a simple type of, you can say, scheduler program. Much has been explained about this reference of how we should handle our sites. Much has been explained. I think that explanation is not small, it's calibered one. It's based on effectiveness of uh, So, what to do? We have discussed about site diary in a practical way. Now I'll move to site memorandum. And we also say site diary in other terms if we see have in logical sequence. We can say, for example, site diary in a way. Site diary, let us say, site diary, what it says in this way. Construction site diary app, site management software. I'm not interested in that. Site diary, construction site channel, site diary, what's site diary, what's daily site diary, what is site diary, why is what's site diary used, construction site diary example, if you helpful, site map, no, it's not that. Let's first of all, what is site diary? Says it refers to as construction log or site journal. Site diary is construction projects record of all its works site progress, including all events and activities that could affect your construction progress and quality of your completed work. It's very good definition. In fact, we can repeat, also referred to as construction log or site journal. Site diary is your construction project's record of all its work site progress, including all events and activities that could affect your construction progress and quality of your completed work. Also, we may say, what is daily site diary? What site diary used for in construction? Site diary records construction progress as well as various occurrences on construction site. This includes, for example, occurrence of construction defects. Thus, documentation around a project is an important basis for clarifying any facts and responsibilities, and that is very important one. Then we can, what site diary must be filled every day? Why site diary should be filled every day? Often most frustrating part of subcontractor's job is getting paid. It can be difficult to prove a particular piece of work has been done, so a well-maintained site diary is a must. It must list work undertaken and can even make a note of unfavorable weather causing delays. The importance of site diary for everyday construction activities and importance of site diary. Why are site instructions important? What is site book? Well, let us see why site diary is site instruction important. There are also site instructions that may result in additional costs. Okay, that we'll see later on or something. So we have gone through what is site diary, and we can have certain examples here. I don't think we can have daily site diary, weather conditions, services, likewise. So we close this now and we come back to our talk, and that is, how does it work? How do we manage to move further? Now we go to site memorandum. What is site memorandum? As we said before, we discussed before, site memorandums briefly written site memo, which is used for purpose of recording, advising, instructions, instructing, and for whatever miscellaneous purpose. That is site memorandum. And site memorandum is just not just because somebody likes it or does not, but site memorandum can also be defined in a professional way, and we can say site memorandum. site memorandum. We said site memorandum headings request signatures from participants of monitoring visit of a final document. Signatures is just different site some say what's memo in construction means that in fact project delivery memos are design and construction documents used to implement any immediate change in any stage of project, from design through advertisement and construction. Memos remain in effect until all appropriate supporting documents can be updated. So what 5 types of memos says. There are different types of memos such as information request, confirmation, periodic report, suggestion and study results memos. Well, means it is certainly very different term. So we have generalization here for site memorandum. You can say that consultant or engineer can write to contractor for some information or for some explanation or whatever we can say that is required on site activities related, what's ongoing on site, what should be, should not be. A common discussion, not a claimable, but just for informative information exchange, and then you can say contractor has a right to respond to that as being complied with or should be complied with, or there is some more, more information required. So site memo usually is a kind of ordinary, it's a kind of, you can say, ordinary correspondence in whatever form you will say, but official one. It's official one, and we have to say that it's record only, unclaimed record. Now it's usually there is no limit on site memos. You can say it's informative records, just to keep in mind and comply with. And we then come to site instructions. Site instructions valid for procedures and communicative information. It's used for confirming certain specific tasks, or if there would be required some changes on the specification or like. Actually, site instruction is a kind, in construction world it's different, means it is like you have a kind of order or instruction given by an engineer on behalf of owner to contractors, and this is official, and you can say that instruction is instruction. Contractor has to abide by that. Contractor cannot say, as far as it's part of work, and if this work lies within scope, it has to be done, and even a lump sum contract can be given. But point only raised is that if contractor thinks that it's cost impactive, it's this impact on cost, in that case it's clearly written on site instruction also at somewhere maybe in footnote. If contractor considers that this instruction constitutes a cost variation, if contractor thinks that this instruction constitutes a cost variation, then contractor has to inform accordingly to engineer about that. Then engineer shall decide whether or not you have to continue this work, and that should be done immediately. So you can say, suppose I get instruction today, and being an agent or being a responsible person, I can assume, I can think that this constitutes cost variation. I have to immediately respond to engineers. We will do it only when you decide about this cost, or you confirm that variation shall constitute. And that's the importance of site instruction. But we cannot deny, contractor cannot deny it's doing. If engineer says no, you have to do it, and also give engineers request you give details of cost impact on this. but you have to work on this. That's, you may say, legal requirement. Here, if you say no, we will do only when you confirm. You have that right as contractor. And in that case, engineer or resident engineer, it's duty to confirm. You carry on this, and you cannot deny that. So that is beauty of site instruction. You can say in hierarchy, number one down, from number down, number one is site memo, and then is site instruction, higher than site memo, that is site instruction. And if you just climb up on that hierarchy of documents, then we say engineer's instruction. Engineer's instruction applies contractually and claimable as empowered as a legal contractual document for purpose of instituting claim. And because engineer's instruction is legal, even if there is site instruction question of constitution of cost variation, then engineer is required to issue engineer's instruction. So that engineer instruction clearly defines cost variation on that. That could be additional cost, or that could be reducible cost, both. So engineer's instruction applies contractually. It's a kind of payment to be given additionally or deduction formally. So engineer's instruction applies contractually and claimable. It's empowered as a legal contractual document for purpose of instituting claims. And that is beauty of engineer's instruction as far as concerned site instruction and instructions. And then it goes to some of the documents. So being a practical engineer, when we get site instruction, we should make sure that whether it lies in is part of a scope of work or it's not part of scope of work, to make sure that we have to do it or not to do. Because if we do without any question, then that claim cannot be raised. Site, now is coming to processing, and that is site technical queries for technical approvals and update are meant for purpose of technical queries. You can say raising clarifications, requests, raising normal, nominal request for proposal on already approved items, submission of each such request that may not impact contractually, and site technical query is something very different but technical. It involves technical questions, it involves technical answers, it raises certain conflicts, or it describes what are conflicts and to request solutions, or it describes something discussed on site for that clarification or confirmation. You must say there may be very many technicals, or we want some, we can say, we want to propose something because some information is not available and we don't feel it's sensible to wait for that information from engineer, and we can propose something which is the right of contractor on contracts. So we can propose and we can make some shop drawing, or we can make some working drawing, or we can provide some other input in form of site technical query. And if that query is responded positively, this means it's approved, but no cost factor can be included in that. That's the main point. site technical query. So it's a technical approvals. So it is an update amendment for purpose of all technical queries. It can be we have to raise clarifications, requests. We have to raise nominal requests for proposal on already approved items, and submission of each such request that may not impact contractually. Engineering queries for designs, clarifications, that's different, but site technical query, you can have a view if you find some information here on site technical queries, because I'm interested in knowing and following as much as possible to you, so that technical query will look, it will look very interesting as much as information we have. Site technical query definition. Technical query is a formal process of asking a clarification or a question from concerned departments involved in execution of project. That's very common now. So we can say a technical query. What is technical query? A request for information, occasionally referred to as a technical query, is a formal question asked by one party to a contract on a construction project to other party. This way they will enhance communication focus process on intended and desired result. And what does technical query mean? That's point. Technical query is formal process of asking a clarification or a question from concerned department involved in execution of project. Technical query can be raised between owners and contractors, between site operations of contractor and engineering team of contractor. What is technical query in question? A technical query is a document containing a question which is raised by one party on a construction project to other party with whom they are in contract. It's a contractual document which requires a formal reply. And what's the difference between technical query and RFI? You can say paper provides a framework for classification of queries in an engineering design system. So its engineering query model should take into account fundamental concepts and requirements of interactive engineering applications. What are queries? We may say, so EQ engineering. What is EQ? Earthquake engineering. That is technical query and fighters. So we explained this. I'll close it down. So we can see now about engineering query for designs, clarification issues. Engineering queries for, we may say that engineering queries for designs, clarification issue, and issued for design issues for confirmations from engineering policies issues adopted. Now we come to construction method statements. It's really very important talk as far as method statements are concerned. Construction method statements for mandatory working requirements can be used for purpose of defining in details about all sequences of whatever works being carried out, or or shall be carried out, which approved statements must be complied with in its entirety and must include scope of work. Now, the requirement is that construction method statements are actually mandatory nowadays. This is a working requirement, and this is used for purpose of defining in details or explaining in details about whatever sequences of works being carried out or to be carried out, which approved statements must be complied with in its entirety and must include safety, attachments. These are titles we can say in method statements. Sequence also we can say. After long gap, video and audio falling, and we therefore say, again I repeat, we may say it is should be what? Should be scope of name of statement first of all. Is scope. What should be scope of that? That is scope of work. Then materials required for that, or we can say this is a reference to approvals, etc. Reference to documents also. It's very important. Drawings or specifications, and then safety involvement, safety, health, and environment all combined. And we can describe responsibilities as well. These are important. Safety responsibilities, work responsibilities, qualities and responsibilities. And we can say procedures or detailed methods. We have to describe with stages of inspections within. Of course, we have to describe inspection stages, and then once this is over, this is, you can say, we have to see certain necessary attachments which can be procedural related or which can be support related, which can be plans as well in major activities. This shall be our plan, and which plan should be technical one, organizational one, that we do as such on this activity. This will be our resources, external resources, and in certain cases this is technical details you have to provide. It's our technical way. We can even say timings we can give in that. Quantity also if required we can give in that. And how shall we control it? That can also be included in that. And there are certain responsible statements in such case. So we can say certain necessary attachments. We can say machines will require this, or whatever manufacturer's instructions also we can, if these are included, we can give with that. So method statement is very important document for purpose of explaining practically on site what shall be done on site, how it should be done, and it should be done by procedure, and that after being submitted shall be, after being submitted by contractor to consultant or engineer, it's duty of engineer to investigate or to review and raise some questions if required, or otherwise approve that. Approval is important so that this becomes an official document for compliance or for implementation. This is subject to changes as well. because this is your own method and this can be reviewed from time to time if required. So once work is done, this becomes a record only. But there may be repetitive methods also which moves on. So we have to take care of that. Give me a couple of minutes. I'll be back and work on this. we say that construction law statements, we define the one that is for specific purpose. And we have said that we rely on these methods. These methods are very important from every point of view. There are many methods. There can be list of methods, long list of methods. Means from taking over site to handing over site, there may be hundreds of methods, sometimes 50, 100, 60, 70, depending on what are typical activities and what are particular activities. This long list we have discussed already, and you know what are activities involved. But here we are going to give you only contents of methods that are involved, and we have to be very specific about that. We have examples. If you wish, I can find out some examples here. You just for refreshing. It's not very big deal. Just a minute, I'll try if I can find that. This case is demonstration is important for everybody. So management documents, we have method statements here, the chapters here, the statements. Likewise, example here is, for example, you can say, I will use better one, Let's say equipment structures, for example, equipment structures, I'm giving my statement here. Equipment structures. This very small statement. Structure, you can say placing concrete surface water tank foundation. So as an index, then we give scope here, then reference document, definitions, responsibilities. What is method? Then equipment, attachment, and also another one say compressor structures. RCC column plate inserts. That is, same sequence, index, scope, documents, definitions, responsibilities, safety, and method. Whatever method, this is method here, and equipment, attachments. And same way, you can say it's another one, crack gas compressor, massive foundations, scope, and here is documents, and we can say responsibilities, definitions, responsibilities, safety, preparatory works, and then we have method, quantification was method here, and we include manpower and general pouring notes. Likewise, that is sample, and same way another one. I just try to explain this statement, and there are so many like that. Just this was indicative, so that I should know I'm talking about this method statement. Then we have to see about shop drawings for work execution. Shop drawing for work execution must be produced to convert services schematic drawings into real fabrication or similar purpose, giving detailed technicalities for purpose to be carried out work on sites. Shop drawings can also be used for purpose of charting out interdisciplinary conflicts or clashes. You may see this is very general term, shop drawings. Means we generally call working drawings as well as shop drawings, shop and working drawings we can call them. But particularly for services items, services disciplines. Example is electrical discipline, electrical shop drawings, mechanical shop drawings, HVAC shop drawings, lift workshop drawing, plumbing shop drawing, drainage shop drawing, not one, not two, or kitchen unit shop drawing. No, there's a confusion in that, but this should be available. Shop drawings, working drawings for work, and these drawings are such that they should be done specifically in a way that it's approved and it should fit in. Schematic drawings do not give fit in, and shop drawings or working drawings just details out information how it shall dimensionally or location wise or section wise, or you may say whatever way, details must be available so that whatever work it involves is carried out properly without any obstruction, without any confusion. And this drawing, shop drawing or working drawing, must be approved before work starts. That work may be fabrication work, or it may be site execution work, it may be shop fabricated work where fabrication is done in shop. This shop may be on site itself. This may be then work to be done on site, which may be called work to be done on site according to details. So shop drawing or working drawing are almost same but having only location difference. And working drawings for work execution means detailed drawings constructed from schematic designs to suit work area per regulations and giving work related dimensions. About first fixed activity. First fixed activity means services first fixed activity to be installed respecting electromechanical services, and it's not, you can say, avoidable. We have to have it every way. In fact, if you don't have shop drawings approved or we don't have working drawings approved, work cannot be allowed to be done, and if it cannot be done, it cannot be approved as well. So we have this mandate on contracts and procedures that all drawings, services, shop drawing or working drawings should be completed in its process, in respective processes prior to its schedule comes in. So that is what we have to be, and we know that these drawings are perfect work of coordination That is purpose of these drawings. We have to make sure that architectural, if not architectural, at least structural services coordination, electromechanical coordination, or you can say electrical engineering coordination, mechanical engineering coordination, or plumbing services coordination, or some other coordination like ducting work is moving within false ceiling, pipe work is also moving within false ceiling, HVAC pipe work, or maybe some other item moving through, beam is coming in between, say down stand beam coming between, and this conduct, the service duct passing through beam, which is not permissible. Likewise, there is no gap left between HVAC duct and electrical cable, or some pipe, copper, still water pipe and cable. Likewise, there is a mandatory distance requirement. That's what we call coordination activity, technical coordination. Particularly, you have to abide by laws. We have to abide by rules, and because during schematic design time, it's very difficult to do all this. It's enough even if structural, architectural, and schematic coordination be done successfully. Now we're talking is detailed coordination, electromechanical coordination, mechanical, civil coordination, civil electrical coordination, or whatever is required. We should keep structure safe. I mean, there should be no conflict between such services, inserts, or such services routings between structure. And for this, because at later stage they shall cause problems. So during execution, where slab or beams or columns are cast and these have relations with these inserts, we have to make sure that such conflicts are resolved as early as possible. Otherwise, you have to immediately take decisions on site immediately if these drawings are not ready, which can cause a delay in pouring of concrete, delay in some other activity, or there can be site decisions on some locations which even shop drawing may not give. So that situation should be avoided if good work is done. It's not line work, it is thinking work. One has to go to sites probably for some surveys, technical surveys on such services. So it's very important issue that shop drawings, particularly working drawings, must be approved, and shop drawings must be approved because it doesn't hold site work in future. All services disciplines require production and submissions of such drawings for purpose of approvals and for carrying out involved activities. Such drawings help in containing interdisciplinary clashes so that works on all activities be done smoothly. Site clarification is required. So now we will take up this site clarification issue later, though it says site clarification is required for purpose resolved, or actually for some ambiguous detailings of whether it's given that details be decided to suit site conditions. So we'll take up this, and since purpose is something different, but we have to be very sure about this if you're talking. Though I wanted to cover more, but it's already 3 hours gone, more than 3.5 hours. Because I'm very much interested and serious about quality and coordination relations. It's very important point because Coordination itself involves quality, and quality is related to coordination because if coordination fails, though coordination is a network system, but decision making is also important. In communications, decisions cannot be taken, but in coordination procedures, decisions are required, agreements are required. Otherwise, there stands no meaning at all. Such agreements which are required can be taken by coordination procedures, and that is purpose of coordination, that both equal persons sit together, they consider issues and they consider problems, and these persons can be from both parties. They decide what to do with that, and the agreement is made without impacting other disciplines, without impacting architectural, structural construction. Those decisions are viable, should be viable without cost impact. And because these are all part of contracts and first class working is required, contract for all services and engineering disciplines. Therefore, I can simply say coordination is a technical job based on communication and based on various others. And that's quality issue without any issue, without any problem, and that's why we can say quality and coordination must be respected. If you really want to be quality engineer, it's your duty. It's your duty to coordinate properly, and coordinate doesn't mean fighting, it doesn't mean dispute. It's professional work that we talk of very importantly. And we can say that coordination, successful coordination, successful coordination based on proper communication, proper you can say proper principles, proper technology, application, we can find solutions to such problems on sites, and those solutions can be included on such drawings for purpose of contractual requirement. The documents must be complete, and that documents can be called even after shop drawings are ready, approved. There can be further changes in terms of whatever site conditions, site clashes which could not be discovered, and those could be recorded as red line marks up also. So this not that is end, or we cannot say line is locked. We can lock it but unlock also by referring to red line markups, which can further be incorporated on as drawings or documents for purpose of as-built drawings. That can be, these red line markers can be affected on original drawings, architectural structure, whatever else, or sections or detailings, and also can be done on shop drawings or working drawings, and also can be done on specifications if required. So it's very important point in coordination work. Coordination is not simple work. It's very much difficult, as well as work which requires concentration, constant attention, constant focus. It starts at pre-contact award, if you are sure that it is going to work, and it goes even until after works is done, works are done, or records are not available. Means it's a kind of work full of intellectualism, full of good information, and therefore it's respectable professionally in all whole works on site. All, you can say, all departments are involved in such type of activities of coordination engineering, and that is the only reason I want to stress on this in a professional way, that engineers preparing for future should know it now, that you cannot run away from coordination even if you are in design engineering or you are in site engineering or you are in planning engineering or you are wherever. You shall come with this. Means this is a kind of general physician, everywhere is required. And general physician, I mean to say, it raises questions to all, and answers have to come from independent, you can say, professional discipline engineer for that discipline. And that's why this is very important one. With this conclusion note, I would like to close this talk today. And I understand, I try to give impetus on this, that just involve yourself in that. It's very, very important issue. Coordination issue, communication issue, quality issue, or work. Work plus quality plus communication plus coordination can say something else, speak together. We have to think about that in every way. If we can do that, we think in that case we can say we did complete engineering, not half engineering. And remind it that without this, designs cannot be claimed to be successful, because shop trying, all this which I told you, coordination is a part of designs as well. It's not execution part alone. It's a part of designs, it's a part of execution, it's part of everything. With this I take your leave. Thanks a lot. And we move on how to close this.